All right, so here's our fifth kind of set of notes for secondary one, term one. And today we are talking about inequalities. So a bit of a terminology. So this is a number line, okay? As you move to the left of the number line, the numbers get smaller. As you move to the right of the number line, the numbers get bigger, okay? Typically in the middle of the number line, we've got like something neutral or like 0, okay? So like positive numbers are going to be big numbers over here. Negative numbers are going to be small numbers over here. All right, so the inequalities that we'll be using are as follows. There is less than, greater than, less than or equal to, greater than or equal to, okay? Those are the symbols that you need to become familiar with. I like to remember that less than kind of looks like a slanted L. If it has a line underneath it, it means or equal to, meaning it could also include that value. Okay, so when you have less than, that means that like this number on this side is smaller than this number. Greater than, this number is bigger than this number. Open or filled in circle basically works like this, okay? If it is just less than or just greater than, it's an open circle. If it's or equal to, like less than or equal to, it's filled in. If it's greater than or equal to, okay, the or equal to part right here tells me it's going to be a filled in circle, which means it also includes that value. So in words, if it says x is less than 2, that means x is, here's our less than symbol, 2. So on my graph, say we've got 0 right here, 1, 2 would be right there. Now x is less than 2. I would put an open circle on the 2, not filled in because it was just less than. And then everything smaller than 2 would be everything to the left. So I'm going to draw an arrow. This would include all of these numbers that are smaller than 2. Okay, everything up to 2. All x values less than 2 would be this left side of my number line until we reach 2. Now if it says x is greater than 2, my symbol is going to be pointing the other way. X is greater than 2. So on my number line again, if I have 0, here's 2, I'm going to circle the 2, open circle, and everything to the right of that, everything bigger than that would be included. So I would go to the right and put an arrow. If it says x is less than or equal to 2, on my number line, here's 0, here's 2. This time I circle it, but I fill it in. And then less than is going to be everything to the left. If it's x is greater than or equal to 2, here's 0, here's 2. Greater than or equal to means I fill in the circle, everything to the right of that number. Okay, so when you are graphing inequalities, these are the steps. First, you want to isolate the variable. So like get x by itself. Then you're going to plot the critical point. That's like your number. You're going to decide if it's an open circle or a filled in circle. Then you will determine the side to shade. So if it's bigger, you're going to shade to the right. If it's smaller, you're going to shade to the left. So for this example, x is less than or equal to -3, okay? So I typically like to plot 0 on my number line. You don't technically have to. I just like it's nice to help people visualize it a little bit. So if this is 0, this would be -1, -2, -3 is right here. So I'm going to, that's my critical point. -3 is my critical point. I'm going to circle it and fill it in because it was or equal to, looking right here. Because it's or equal to, I fill it in. And then to the left, because it was less than or equal to. If it was greater than, I would have gone to the right. Okay, so I plot -3. It's a filled in circle. And then it's everything smaller than that. Next example. This time I have x is greater than -1. So here's 0. And I get to kind of choose where to put 0. That's just a number line. It's just a graph. So I'm going to label that. There's my 0. If that's 0, then right here is -1. So I'm going to plot my -1. I'm going to have an open circle. Oops. Said one thing and did something else. Oh, that's not what I wanted either. Okay. Come on. This thing is great most of the time. Ugh. Go away. Ugh. Okay. We're going to do this again. Let's do it in red. Okay. Open circle. Not filled in. Open circle. Okay. Sorry that it looks filled in on my paper. And then because it's greater than, I'm going to go everything bigger than that number. So that's to the right. Okay, again, it's open circle. And then everything to the right. Okay, let's keep going. Number 3, it's called set builder notation. It says the set of all x values, that line means such that x is greater than or equal to 4. This is the exact same thing as if I had just said, hey, do x is greater than or equal to 4. Okay, it looks fancy. It's not that much different. So the number I'm going to plot, if this is 0, this would be 1, 2, 3, here's 4. Okay, I'm going to do a or equal to. So filled in circle on 4. And then greater than means it's everything bigger. So everything to the right of 4. Next problem. Okay, so again, this is the set of all x values such that 5 is greater than x. Okay, now I'm going to be honest. I hate reading it that way. I know you can reason it that way. If you can, good for you, go for it. I don't think it's clear for students when I write it that way, so I always flip it, okay? I'm going to flip my inequality. If it says 5 is greater than x, that means x is less than 5. Okay, notice how I flipped everything? So like reading it in reverse, if 5 is bigger than x, then x must be smaller than 5. And that's what I'm going to graph. So on my graph, say here's 0, 1, 2, 3, 4, here's 5. I'm going to circle the 5. I'm going to leave it open because it was just less than. And then I'm going to go everything smaller than that. So everything to the left. All right, when you are writing an inequality based on the graph, we kind of go in reverse. Okay, so the first thing I noticed looking at this problem, my critical point is right here. Okay, so it's 1 is my important number. Okay, so it's going to be all x values compared to 1. Now, because it's going to the right, it's greater than. And because it's an open circle, it's just greater than. Not filled in, no equal sign, so just x is greater than 1. That's the picture on my graph. On the next problem, here's my special point. It's 0, okay? So my x values are being compared to 0. See how it goes to the left? So it will be all x values less than 0. Open circle, so no equal sign, just x values less than 0. That's what my graph shows. On number 7, my special point is -3. So my x values are being compared to -3. It's to the right, so it's greater than. and see how it's filled in or equal to. So this is all x values greater than or equal to -3. Next problem, critical point right here is 3. My x values are all x values to the left of 3, all x values less than 3. See how my circle is filled in on the graph? That means it's less than or equal to. All right, next problem. We want to tell whether the value is a solution of the inequality or not, okay? So look at this value right here. If I take 19 and I plug it in for D right here, I would have 19 minus 7 less than 12. And I just want to see, is this a true statement or not? What's 19 minus 7? 19 minus 7 is 12. Is 12 less than 12? No. 12 is not less than 12. This is 5. So 19 is not a solution of this equation. If we got a true statement, yes, it would be a solution. We did not. It was false, so it's not a solution. Next problem. I'm going to see if I plug 1 in for n right there, do I get a true statement? Okay, so 9 is greater than or equal to 3 times n. I'm going to plug 1 in plus 6. Okay, so I want to know, is 9 greater than or equal to, let's simplify this right side of my inequality. 3 times 1 is 3. When I add 6 to it, 3 plus 6 is 9. So, is 9 greater than or equal to 9? Yes, it is. That's true. 9 is equal to 9. Could be greater than or equal to 9. It's equal to it. So, that means 1 is a solution to this inequality. Okay, one more thing to kind of talk about in these notes. We are supposed to translate sentences into inequalities. I know that most of you don't love doing this, okay? It is something we're going to practice. It is something that's good for you. So, a little like translation guide for you. Words that tell you we're doing subtraction would be minus, less than, decrease, fewer than, subtracted from, or difference. Those words mean, hey, we're going to use subtraction. Multiplication, if it says like twice, that's like 2 times. Product of, that's multiplication. Times, of in math, those are all signals that we're going to do multiplication. Addition, words like sum, greater than, increased by, more than, added to, plus, that tells you addition. Division would be words like quotient or divided by. And then equal or is. Greater than, less than, all sorts of different translation things that we need to do, okay? These should be pretty simple. I know it might be a struggle. I'm happy to help you with it and walk you through them on your practice as well. Okay, so on number 11, it says 12 is greater than or equal to 5 times a number. Okay, 12 is means equals. Greater than or equal to, though. Oh, that's a little bit different. Greater than or equal to. So instead of just 12 equals, it's going to be 12 is greater than or equal to. Okay? 12 is greater than or equal to 5 times a number. So 5 times a number. I don't know what that number is. I'm going to call it X. There we go. That's it. 12 is greater than or equal to 5 times a number. And I translated that into an inequality. Next problem. This time it says 7 is less than or equal. So less than or equal to the difference of a number and 6. So difference, remember, means we're subtracting. The difference of a number, I don't know what it is, and 6. So I find the difference of a number and 6, I subtract those. 7 is less than or equal to that difference. Last one, the sum of a number and 14. So sum, remember, sum means adding a number, I don't know what that number is, I'm going to call it x, and 14. The sum of x and 14, the sum of a number and 14, is more than, that means greater than, 6. Ta-da! That's the end of your notes for today. Now practice, practice, practice.